Hello. So this section is 2.5. It deals with polynomial and rational inequalities. It's kind of a nice section to learn at this point because there's actually no new material. We're just going to be sort of solidifying a lot of the material we've been working on the last couple of days. Okay. So let's start. Let's say we have a graph like this. We're going to do a polynomial one. So let's say it looks like so. So this point here is at -1, +2, and +4. Okay, so we're going to say this is some function y equals f of x. Okay, so now we could ask, so this is -1, 2, and 4. We could ask a bunch of questions. We could ask, well, when is f of x strictly greater than 0? So when is f of x strictly greater than 0? So you pick the x values, right? So you're going to pick the x values that are before -1 and between 2 and 4. All right? Now, since this inequality is strict, you have to be strictly greater than 0, you're not going to include the endpoints. Okay, so you're going to have -infinity to -1 together with 2 to 4. Okay, so this is indicating we are not including the endpoints. Okay, we could also ask, for example, when is f of x greater than or equal to 0? Okay, we could ask when is f of x greater than or equal to 0, and for that, well, pretty much almost the same, except for now we are going to include these endpoints. So how do we include the endpoints? We make those brackets. So never include infinity or -infinity. -1 with a good solid square bracket there. And then from 2 to 4 with a square bracket. Okay? And you could also actually ask, when is f of x less than 0? When is f of x less than 0? Well, definitely between -1 and 2, right? But again, we're not including the endpoints. Okay, we're not including that -1 or that 2. So, and then again, 4 to infinity. Okay. And of course, let's just, for completeness, let's do in this case, f of x less than or equal to 0. All right. So now this is very similar to this one, except for now, we are allowed to include these endpoints. Okay. We never include infinity. We never include infinity. So -1 to 2 together with 4 to infinity. Okay. All right. So that's how to do it based on a graph. Let's take a look at, let's say, an example where we're given the algebraic expression. Okay, so let's take f of x equals x squared times x minus 4 times x minus 7 greater than or equal to 0. Okay, now I'm going to go ahead, I'm going to do it real quick with the sign chart, just so you guys can see this is why I like doing or teaching the sign chart for you guys. So, where are my roots? My roots are at 0, 4, and 7. And then along the side, I'm going to have x squared, x minus 4, x minus 7, now x squared. X squared is a parabola, right, which is positive except for at its 0. So positive, 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 positive. X minus 4, y equals x minus 4. If we look at that, that is a line that slopes up. So that means it changes from being negative to positive at its root. Its root is at, of course, at 4. Okay, so negative, negative, positive, positive. And x minus 7 changes also from negative to positive, but at 7. 2 negatives is positive, again positive, negative, positive. So when is this greater than or equal to 0? Between 4 and 7. Sorry, my bad. Between, my bad. Between negative infinity and 4, and then again 7 to infinity. Okay. Okay. Now, just as a sort of sanity check, or as a, well, just sort of to like see, I want to explain what happens if, let's say, our question was f of x is x squared, x minus 4, x minus 7, greater than 0. So how does that change our answer, if at all? Well, what happens is now we can no longer include the zeros. So 0, 4, and 7 have to be thrown out. Okay? So our new region would be negative infinity to 0. We're throwing out 0. From 0 to 4. And then again, from 7 to infinity. Okay? Now, I'm going to just real quick show you guys how you can do this by graphing. So let me put a axes on there. Okay. My zeros are at 0, 4, and 7. Okay. Now, what's my end behavior? If I look at this, this is x squared. So there's 1, 2, 3, 4 x's, right? 1, 2, 3, 4. So the leading behavior is like x to the 4th. That means it looks like this out at the end. So it's going to start out way up here, bounce at 0 because it's an even powered 0. Okay. Cross at 4 and cross again at 7. Okay, so you can see from the graph, okay, just like we had, it is positive here before 0. That's this positive. Between 0 and 4, it's again positive. Okay. And then after 7, it's positive again. Okay. So you can see how the sign chart matches with the graph. Okay. All right. Let's go ahead and take it to another video.